Welcome to Lesson J. Well, we've been solving a lot of 2x2 systems lately. Learned how to solve them by graphing. Learned how to solve them by the substitution method, by the addition method. I think it's about time we started actually looking at where do these 2x2 systems come from? Like, why do we solve 2x2 systems? Anyway, who makes these things up? And it turns out lots of people make these things up. There's lots of situations where 2x2 systems will evolve. So we're going to look at 5 types of situation in this lesson. 7 examples, 5 types. And just to get a taste for, where do these things come from? Speaking of taste, our first application is mixing some coffees together. Now this is actually a real world thing because I know a guy that does this kind of stuff. So Sven, that's not his name, but whatever. Sven, he really likes coffee A. Really likes it, it's good. Now the problem with good stuff in this world is it's expensive. The coffee A is $20 a pound. And poor Sven, he can't justify spending $20 a pound for coffee, not considering how much he drinks. So he's like, man, I love it, but $20 a pound? What am I, crazy? So what's he do? He gets some cheap stuff and he mixes it in. So he mixes in some of this coffee B, we'll call it, which is only $4 a pound, so that's cheaper. And so by mixing some in, it brings down the overall price, and then you can sleep at night. Okay, so that's the situation. That's the scenario here. So here's a math problem we have. Let's say Sven here, he has 10 pounds of his good stuff, and he wants to dilute it a little bit. He wants to add some of the cheap stuff, bring the cost down. So how much cheap stuff? That's the question. How much cheap stuff? How many pounds of the cheap stuff? He wants the final blend to be not $20 a pound, but he could accept $15 a pound. How much of the cheap stuff does he need to add here? Okay, so I hope you agree that's a real kind of a problem to have there. Let's see, we're dealing with coffees, right? We've got these 2 coffees, coffee A, and we got this coffee B. We're dealing with some things like dollars, right? That's $20 per pound. That's $4 per pound. We're spending some money here. And by the way, we've got pounds, don't we? We have to use so many pounds of this, 10 pounds of this. Yeah. So we got pounds, we got dollars, we got 2 kinds of coffee. We got all kinds of things flying around here, don't we? So typically, what's a good idea is to try to organize all this information in some kind of a table. So get one of those green accountant pads, or at least imagine getting one of those green accountant pads. The accountant pads where they have all the lines and columns and they start entering their stuff here. That's kind of what we want to do. We're keeping track of the money. We're keeping track of the pounds. We're keeping track of the coffee. Make a little table here. So I'm going to say, okay, what do we got? We got coffee A, and I'm going to maybe right next to it, to further describe coffee A, I'm going to say this stuff is $20 per pound. We also have coffee B, and this stuff is $4 per pound. So that's kind of my description of coffee A and my description of coffee B. And then what we're going to do is we're going to mix them together, right? So in accountant speak, I guess that would be the bottom line. So I'm just going to call it a mixture. Okay. Now, we want to keep track of how much we're using, of course, how many pounds. And we also want to keep track of how much are we spending, the cost in dollars. So I set up a little table. Keep track of our stuff in this little table here. It'll help us figure out what do we know and what do we not know and this kind of stuff. It helps us keep track. Now I need to pause for a second and say that I'm going to show you one path through this table, but you can take different paths to the same solution. There are many ways to fill in this table. You might start here and fill it this way and this way. You might start here and fill it this way and this way. You might start here and fill it. The point is, different people will fill in their tables different ways. In fact, I've taught different ways of filling in this table. So the goal is not so much to memorize steps or something. First you go here, first you go there. The goal really is to, how should I say, is to talk your way through it. Just ask yourself, what do you know? What do you not know? How can I figure out what I don't know from what I see in front of me, et cetera, et cetera, et cetera. So I'll show you what this looks like. But I emphasize, this is just one example. Other people could solve it different ways. And eventually you want to be doing it by yourself. Say, well, I feel like filling in the table this way. In any event, start filling in the table. So what have they told us? They told us coffee A, yep, $20 a pound. I've got that information in there already. Right, I got that right there. Cool. We mix in some cheap stuff, which is $4 a pound. Yep, I got that information right there. What else do we know? He has 10 pounds of good stuff. Oh, I should write that there. He has 10 pounds of that good stuff. Cool. He's got some good stuff. He's got 10 pounds. How many pounds? That's a question, so we don't know what. How many pounds? We want the final blend to be $15 a pound. I guess I could put that right there, right? It's going to be $15 per pound. I mean, if you want, you could put this in a make this into 2 different columns if you wanted to. I don't really feel the need to do that. I'm just, this is what the coffee A is. It's the $20 stuff. And this is what coffee BB is. It's the $4 stuff, and so on. And the mixture is going to be $15 stuff, $15 per pound. Anyway, we're kind of already done filling in what they told us, right? They told us, hey, 10 pounds of A, and now we have to answer everything. Well, actually, we have to figure out how much B, right? But now the rest of the table is waiting for us to fill it in ourselves. We want to try to fill in the rest of this table, as much as we can anyway, ourselves, just by looking at what we got in front of us and saying, well, what does this mean? Like, for example, what does this mean? $20 a pound, 10 pounds? That kind of tells you something, doesn't it? If you're buying 10 pounds for $20 each, well, heck, it's going to cost you $200. Might as well put that right there. It's going to cost you $200. See, we can figure that out. Now, how many pounds of coffee B are we using? Don't know. Really don't know. So that's what X is for, right? You say, I don't know. Do I have a clue? I don't know. I'm going to call it X. But what I just did here, I can now do that here. I can say, well, if I know that I'm buying this many pounds and they cost $4 each, then I know that I can multiply those two things together to figure out how much I'm spending. So the $4 a pound times the X pound gives you the 4X price over here. So that's pretty cool. Okay, so now we got this bottom row. What's going on here? How much mix are we going to have? I don't know, but I know how much it's going to cost. It's going to be $15 each, right? So I can put the 15Y over there. The table's all full. That's nifty. Now that the table's all full, now that the table is all full, it's time to, what I say is extract equations from it. How do you extract equations from it? Well, one thing you might do, here's a clue. We were just kind of crossing the table this way, right? We said, hey, $20 a pound, 10 pounds, blah. $4 a pound, yeah. Well, think about crossing the table a different way. Come down this column. 10 pounds of this, X pounds of this, Y pounds of this. Well, is it the mixture? Don't you make the mixture by taking this and adding this to it? Right? So that means that this 10 pounds adding this many pounds is going to get me this many pounds. And that's a nice equation. 10 plus X equals Y. Ain't that something? And you could say the same thing for the dollars over here. If I spend $200 and then I spend this much more, haven't I just spent this much total? Yeah, the whole mixture cost this much. It was this much for the A, this much for the B, and this much altogether. So these two things have to add up and equal each other. So let's see how many times I have to backspace here. Okay, so that's another equation. The 200 plus the 4X have to add up to 15Y, right? this much money plus this much money equals this much money. Lo and behold, that should probably be capitaled. Behold, a 2x2 system. In principle, we have already solved it because we know that whatever the solution is to the 2x2 system, that's the solution to our problem. Of course, we might as well finish solving it, right? So I'm going to get out a different color here. Let's solve this system. Let's not make a graph. You want to use substitution or do you want to use addition? It's your choice, really. I'm going to use substitution, though, just because I feel like it. Because I think it's begging for it. See how this equation says y is the same as 10 plus x? So what I'll do is I'll take this y and I'll replace it with the 10 plus x. So I got a 200 plus a 4x on this left side equals a 15 times substitution time 10 plus x. And we're almost home. 200 plus 4x equals, that's 150, that's a 15x. Okay, cool. I suppose I could subtract 150 on both sides, giving me a 50 plus a 4x equals a 15x. Now why did I do it that way? Because I wanted to do this next. Subtract 4x on both sides and have a nice positive x term. 50 is equal to 11x. Having done that, now I want to switch the two sides around because x on the right makes me anxious. So I'm going to just switch the two sides of the equation around. If 50 is 11x, then 11x must be 50. Anyway, finish by dividing by 11. And what do you get? You get 4 and 6/11. 11 goes into 50 4 times, which is 44. You get 6 left. 4 and 6/11. Now, did I make a decimal out of that? I did. If you make a decimal out of that, if you take 50 and divide it by 11 on a calculator, you'll get about 4.56. What's that? That's x. And what's that? X is this. X is how much pounds of coffee B are we using? And we can stop. We don't even have to solve for y because that was the question. How many pounds of B should he add? So that's the answer. He should add 4.56 pounds. I don't need the y. I get the y. I don't need the y. Yeah, actually, I don't need the y because I can go like this. 10 and this. This must be 14.56 pounds total mixture, right? Anyway. Nice solution, huh? I like it. That was cool. Now you know how much coffee to add if you want to bring your $20 stuff down to whatever. Okay. Now we're going to do something that's kind of similar. I'm going to mix some nuts together. Peanuts are $8 a pound. Pistachios are $14 a pound. You want to make up 12 pounds that cost $10 a pound. So this seems to have slightly different phrasing to it. It's not just that it's nuts instead of coffee, but it seems to have different phrasing to it. So what you do is you say, who cares? I'm going to start by making a table. What have I got? I got peanuts. And how much are they worth? $8 a pound. Okay, fine. Like I say, some people like to split this into two columns. I don't particularly see any reason to do that. It's the peanuts. They're $8 a pound. Okay, cool. Then we've got, what do we got? Pistachios. And they're going to cost they do cost $14 a pound. And then we're mixing them together, so our bottom line is we have this mix. And actually, they're telling us the mixture should be $10 a pound. So there, I've got my full description of my various items here. Peanuts, pistachios, and mixture. As before, there's basically two quantities to keep track of, the money and the pounds. So you buy a certain number of pounds, you have to pay a certain amount of money for that. Okay, cool. So I've got my table set up. Now let's see what we can enter into the table. Anything extra we can enter into the table. Let's just from what they said. It does about 40. How much? 12. Oh, we're going to make 12 pounds of a mix. They told us that. 12 pounds of a mix. Okay, cool. They told us that. So we've got a 12 that we can put in there. So that's something. That's supposed to be a 12. How does this stuff happen to me? That's a 12. Come on, man. Okay, so now we say, how do I fill in the table? Using an X here and there if I have to, but how can I fill in the rest of the table? And again, I bring your eye to this. $10 a pound, you're gonna have 12 pounds. You could fill that in right away. That's going to be $120. So the total mixture is going to cost 120 bucks, right? Just work it across this way. 10 bucks a pound, 12 each. Now, how much peanuts are we going to buy? Don't know. I'm going to use an X for that. But I know that if I buy X pounds, it's going to cost 8X dollars. And then how much am I spending for, how many pounds of pistachios am I going to get? I don't know. I guess I'll use a Y. But I know that if I buy that many pounds, it's going to cost me 14Y dollars. Okay, so that's kind of fun, right? Just fill in the table. And I got all kinds of stuff filled in here. Let's get that out of the way. Okay, now it's time to extract an equation or two. Since we have two things we're solving for, we usually want to get two equations out of it. We're not going to be able to solve for two things unless we have two equations. That's why we have 2x2 systems. Anyway, extract some equations. So we were already walking across the table this way, so you want to start doing something a little different. So you think in terms of sort of looking at the table in an up-down direction. And as before, you can say, well, if I mix this many pounds peanuts with this many pounds pistachios and I get 12 pounds altogether, well, that's an equation. The X and the Y must add up to 12. In terms of money, if I spend this much on peanuts and this much on pistachios, I must be spending this much altogether. And so that's an equation. 8X plus 14Y equals 120. Behold, a 2x2 system of equations. Ain't that something? We should solve this now, right? Substitution doesn't look like a bad method, but maybe I'll do the addition method just to be different. So I'm going to multiply this equation by a -8. Tuck it under here. -8x minus 8y equals a -96. Because then I can add these two equations together and the x's will go away. So 14y minus 8y, that's a 6y. 120 minus 96 is a 24, right? And so that's telling me that if I divide both sides by 6 here, that's telling me y must be exactly 4. And then you say, what's y anyway? You come back up to your table and you can remember what the y is because it's right there in your table. Because it's right there in your table. It's how many pounds of pistachios. That's what y is. So cool beans. I've got an answer. 4 pounds of pistachios. And then you could come down and solve your system for x if you wanted to, but you could also look at the table and say, well, something plus 4 equals 12. I guess that must be an 8. I suppose you could verify, come down here and make sure x equals 8. But, well, look, it says it right there. It says the same thing. You have to add them together to get 12. Okay, so anyway, that's the answer. So we're going to use 8 pounds of peanuts. And we're going to use 4 pounds of pistachios. It's kind of fun after a while, ain't it? You know, you just get to fill in your table and analyze it a little bit, and you get some nice answers there. Okay, I wanted to throw this one in. Do I want to throw it in now? There's the question. Yeah, I guess I'll throw it in now. We're on the nut page. We might as well do the nuts. This one's a little different. Let's see. Peanuts, $8 a pound. Okay, that's the same. 20 pounds of peanuts on hand. You'd like to use them up. How many? I guess this isn't that different. This reminds me a lot of our very first problem. And besides, you need to learn to be fearless. You see a problem, what you do is you say, I don't care if it looks weird. I know how to start. I start by making a table. What I got here? I got some peanuts. And what are they? They're $8 a pound. So I'm just going to write that down there. I also got some things. And they're, what, $14 a pound. Okay, cool. I'm making my table here. And then the bottom line is when I mix them together. And they're telling us here the mixture, we want the mixture to be $10 a pound. So there, I got my 3 items that I'm playing with here. As usual, there's the number of pounds, and then there's the cost. Just like an accountant, right? The accountant's got to count the money. What they call them bean counters because they count the beans and then they count the money. Here they're counting the nuts and then they count the money. Anyway, so what have they told us? Peanuts cost 8. Yep. Pistachios 14. Yep. 20 pounds of peanuts. Goes right there. You would like to use them up. How many pounds of pistachios should you use? Okay. If you want it to cost $10 a pound. Okay, cool. We're ready to fly, I think. So, pistachios, $14 a pound. Or, well, let's start here. Remember, I can multiply these two things across to figure out how much that is. 20 pounds, $8 each is 160 bucks. Cool. How much are the pistachios going to cost? Well, it's $14 times however many we're buying. So it'll be 14x. Cool. And the mix is going to be $10 per pound times however many we're buying. It's going to be a 10y. Cool. I filled in my table. Nifty difty. Now let's extract some equations out of it. You could say, well, 20 plus x must add up to y. That's one equation. And then the money has to add up. The 160 plus the 14x has to add up to the 10y. That's not bad. I think I'll use substitution method again. Take the 20 plus x, shove it in there. So what I got is I got a 160 plus a 14x is equal to 10 times a 20 plus x. And if I bring that up here to solve, 160 plus 14x equals 200 plus 10x. Okay, if I subtract 10x on both sides, I'll have a 4x. And if I subtract 160 on both sides, I'll have a 40. And boy, this comes out nice. 10. So the x is 10. Where's the x? The x is here. What's the x? The x is how many pounds of pistachios? 10 pounds of pistachios. Wasn't that the question? That was the question. How many pounds of pistachios? The answer is 10. Add 10 pounds of pistachios. Cool. Here's another type of situation you can encounter. Solutions. Meaning percent strength of solutions like medicines and stuff. Antifreeze, whatever. So this is a real situation too. They actually do this at various pharmacies. What do? They keep on hand, let's say you've got some kind of a drug, Fix You Good. It's a real good drug. It fixes you good. Fix You Good. Copyright pending or whatever. But anyway, she has two solutions. She has Jug A, which is 80% strength. That's pretty strong. Also has Jug B, which is only 30% strength, so that's rather dilute. And the reason you keep two jugs on hand is because doctors might order anything from 35%, 40%. They might order 60%. They might order anything in between 30 and 80. So by mixing some of the weak stuff with some of the strong stuff, you can prepare any concentration that's in between 30 and 80. So it's actually kind of a slick idea, I think. So, Frey the pharmacist keeps on hand 2 jugs. Question. Dr. Dan orders 20 milliliters of a 50% solution. How much from each bottle? You can see how that feels kind of the same as what we've been doing. How much of each nut? How much of each coffee or whatever? How much of each from each jug? It's the same. It's all the same stuff. So we'll start by making a table. We have this jug A that we're thinking about, and the jug A contains an 80% solution. We have the jug B, which contains a 30% strength solution. And then we have the Dr. Dan's order. And what he's ordering is a 50% strength. Okay, so there's my items over here. I got the jug A, the jug B, and what the doctor orders. Doctor orders 50%. So we got to keep track of 2 things. Now, there's the amount that you grab, I guess. The amount used. And what's the other thing? Well, the other thing, it turns out, is the amount used. That's a mixture. That's mixing whatever this drug is in with, I don't know if it's water or what they're mixing it with. Let's just say it's water. The amount used is the 2 things combined, the water and the drug. What you also want to do is you want to concentrate on the drug itself. How much drug is in the actual... If you were to take 10 gallons of this stuff, half of it is drug. See what I'm saying? It's 50% strength, means the 10 gallons is half drug. The other half is water or whatever it is. I don't know if it's water, but something. Saline, who knows what it is. But anyway, that's the basic idea. So you want to focus on the 2 things. How much is used? How much do you take from the jug? And then how much of that stuff that you took out of the jug is really the drug, as opposed to just filler. So, can we fill in Can we fill in any of these spots? I said oops. Can we fill in any of these spots with information? So, Frey the pharmacist keeps on hand. Jug A 80%. Yep. Jug B 30%. Yep, we've used that information so far. Dr. Dan orders 20 milliliters. Oh, okay, now we got a number. 20 milliliters of a 50% solution. Yep, I got that here. So how much from each bottle? How much from each bottle? Okay, cool. Okay, cool. So that's what we know. That's what they told us directly. Let's start trying to fill in the bottle here, or the table. Fill in the table here. Well, again, we can do this kind of a thing. We can say 50% of 20 means we're going to actually have 10 milliliters of this drug, this fix-you-good drug. The 20 milliliters of liquid that you pour is half drug and half something else, half water, half whatever. So anyway, we got that part figured out. Now we can go across the table this way. How much are we taking from jug A? I don't know. So you use an X for that. How much of that will be drug? Well, you take 80% of that. 80% of the X. How much from drug B? I don't know. But 30% of that has actual medicine in it, or is medicine. Okay, well, the table's filled in. Now let's cross the table in a different sense. You know that if you use X of this and Y of this and it comes to 20 altogether, that means the X and the Y must add to 20 milliliters. And you also know that if you have this of this, this much of this, it's got to add up to the 10 milliliters. So that's the 0.80X plus the 0.30Y is equal to the 10. And you can see we've got our nice 2x2 system of equations ready to go. Now, did I solve this already? Yeah. Let's not have you watch me solve. You know how to solve these things, right? So please solve as an exercise. Just to, what you should get is you should get that you're getting 80 milliliters from jug A, and you're taking 120 milliliters from jug B. That's our answer. Now before we move on, let's just chew on that just a little bit. Does that seem like a reasonable answer? You didn't expect me to ask you that, did you? Does this seem reasonable to you that it would be 80 and 120? Well, here's how you can judge it, at least in part. You can say, okay, look, this stuff is pretty strong, 80%. This stuff is not so strong, 30%. If you took an equal amount from each jug, 10 gallons of this, 10 gallons of that, whatever. If you took an equal amount from each jug, could you predict what the percent strength would be? If you took equal amounts, you'd end up at the average strength, the average of the two numbers, the average of 80 and 30, which is, what the heck, 55. So if you took equal amounts from each jug, you would end up with 55% strength. Was that our goal? No, our goal was to go a little weaker than that. A little weaker than that. That means we want to take a little more of the weak stuff. See what I mean? If we took equal amounts, we'd end up at 55%. That's too high. You want it weaker. So you don't want to take quite as much as that. You want to take more of the jug B. Is that what we did? We sure did. We took more from jug B. So at least in that sense, we can say, yeah, our answer seems reasonable. It's good to chew on this stuff, especially when, you don't get partial credit for an incorrect response. You really want to have ways of looking at these things and say, how can I be sure that I've done it right? And that's one way to say, look, it's reasonable. That's good. Okay, here's another one of these percent concentration ones. This one's pretty cool. Your 5-quart cooling system presently contains a 30% antifreeze solution. Now this is a Minnesota problem. In order to beef up to 50% strength, which is what you need in Minnesota winter, you need to drain some off and refill with pure. Okay, cool. So how much are you going to drain off? Well, at first, I'm not thinking about what's my equation going to look like. I'm not thinking about, how is this, how is this going to end up solving? I just think in terms of, I got to keep track of what's going on. I need to make some kind of a table. What have I got? I got a 5-quart cooling system. Okay. And what am I going to do? I'm going to drain some. And then what? I'm going to add some more stuff to it or whatever. So let me see how I did this. Maybe think in terms of begin with not 50%. We're beginning with 30%, right? Begin with 30%. That's what we're beginning with. And then the questions, of course, can be how much? 5 quarts. They told us that. And so how much is antifreeze? Is actually the antifreeze. And I'm starting to fill in the table even before I make it. But 30% of 5, you multiply the 0.3 times the 5, and you're going to get 1.5, right? So you just go 30% of this is this. Okay, cool. So you can kind of see a table starting to shape up here, even though I haven't made any more rows yet. So I began with that. So what am I going to do? I'm going to drain some off. Okay, so drain some. And what I drain is going to be 30%, right? Because it's coming from the same spot. Then I'm going to add back some pure stuff. The pure stuff's going to be 100% strength. And I'm going to end with 50%. Okay, so I kind of got a big table here, I guess. So I begin with 30%. This is the bottom line here. I begin with 30%. 30% of this is 1.5. Okay. I'm going to drain some. How much am I going to drain? I don't know. I should change colors because I usually change colors at this point. How much are we going to drain? I don't know. How much antifreeze will I be draining? Well, same idea. 30% of this is going to be like the actual antifreeze. And so 0.3x is coming out of the system. Okay. Now I'm going to add some pure stuff. How much? Well, I don't have to use a y because what I'm going to do is however much I drain off, I'm going to refill it, right? So I'm going to add the same amount back that I just took out. So that's going to be an x. Okay, so you don't have to use a y if you actually know that it's the same as what you already used x for before. I already used x to stand for how much I'm taking out, and that's going to be how much I put back in, so cool. Now in terms of how much antifreeze is in that, well, it's all antifreeze. 100% of it. All of it. Multiply by 1.00 if you like. It's all antifreeze. Maybe I will just emphasize. It's all antifreeze. Now I'm ending with 50%. How many quarts am I ending with? Well, again, I'm ending with the 5 quarts. I began with 5 quarts. I want to end with 5 quarts. I can't end with more than 5 quarts, and you don't want to end with less than 5. You're going to end with 5 quarts. And then how much of that is going to be antifreeze? Well, that's the part where you say 50% of 5 is what? 50% of 5 is 2.5. Okay, cool. Notice something different about this table. It's only got an x in it. There's no y's. There's no y's. Well, that's actually okay. That's okay. That means we're going to end up with something really nice. Now I could look down this column. What is that column telling me? That column is telling me that I'm going to start with 5 quarts. I'm going to drain some off. Then I'm going to add back the same amount, and I'm going to end up with 5. Kind of a cute equation, right? 5 minus x plus x equals 5. Well, that equation is solved no matter what you use for x, right? You could use 10 for x. It'll still work. But now come down this row. I start with 1.5 quarts. That is actually the antifreeze part. I'm draining 0.3 x's. Then I'm adding back 1.00 x's. And I'm ending up with 2.5. Now that's a nice equation too, because we can solve that lickety-split. 1.5, combine your two like terms, that's a plus 0.7x equals a 2.5. So 0.7x, if I subtract 1.5 on both sides, I get a 1. So you divide both sides by 0.7, and what you end up with is, what I get? What? I didn't solve it? What are you, nuts? Okay, you end up with 1 divided by 0.7, which is just about 1 point, depending how accurate you want to be, 1.4. So you want to drain off 1.4 quarts and add back 1.4 quarts of pure antifreeze, and your 30% system will be beefed up to 50%. That's practical math right there, folks. Okay, but just to show you that these 2x2s come from all kinds of places, let's look at yet another example. I got two more examples, actually. So this one is money. This is a real-world example, especially as you get towards your retirement or something. As you get a little older and you start to have actual money in your retirement account. So we've got this guy. What's his name? Theodorofson. We could probably call him Ted. He has $100,000 in his retirement account. Okay, cool. Now, he needs to specify an allocation between two investment classes. A safe investment class, which will give him 2% return. Safe is nice. I like safe. But there's also an aggressive option, which promises 10% over the long haul. And that is actually what the stock market theoretically gives you over the long haul. It goes up and down quite a bit, but over the long haul, supposedly it gives you 10%. So anyway, after much deliberation, Ted decides he's going to balance risk with reward. You know, the stock market, 10% is great, but it's risky. It could crash. He's going to balance it by trying to get 5% overall. So how much does he have to put into each investment class? You put some in the safe, you put some in the risky. If you put it all in the risky and it worked, you'd get a 10% return. That'd be cool. If you put it all in the safe and it worked, you'd get a 2% return. Not as cool. Safe anyway. So he's trying to get something in between. So just like when we were mixing the two strengths of solutions together, you mix a 10% with a 2%, you should get something in between, and we want to get 5%. So, okay, how much should we take from each then? Or how much should we put in each? You smell a table? I smell a table. So we have the safe investment to think about. And the safe investment, how do we describe the safe investment? It promises or guarantees or whatever a 2% return. Then we have the aggressive, which promises a 10%. And then we're going to have so-called bottom line. What do you want to call this? The net result or something? Whatever you want to call it. Net result, bottom line, whatever. But we're trying to get a 5%. I know what I should call this, the overall. We're trying to get a 5% return overall. There's our table. Those are the three things we're keeping track of. The safe investment, the aggressive investment, and the overall results. What are the things we have to keep track of? We have to keep track of how much are we putting in each, right? So the amount, what do you want to say, deposited or whatever? Amount invested, something like that. And then the return, which is like an interest. What's the return on the investment? So, going back to our table, what can we fill into this table that they just tell us outright? They tell us outright he has $100,000. That's the total. $100,000. Cool. He needs to specify an allocation, safe one 2%, aggressive one 10%, after much deliberation 5%, blah, blah. They don't tell us anything else. I mean, they describe the investments, but they don't tell us anything else. So now we get out a new color and we try to fill in the rest of our table using our thinking caps, I guess. And I love it when I have two numbers like this because I say, oh, I can figure this out right now, because 5% of 100,000 is you take the 100,000, multiply by a 0.05, and you will get 5,000. Right? Right. 5,000. Cool. How much we putting in the safe? I don't know. What's the return going to be? It's going to be 2% of it. And you figure that out by multiplying the x by 0.02. How much we putting in the aggressive? I don't know. What's the return going to be? Well, it's going to be 10% of that, which you get by multiplying the y by 0.10. Okay, cool. So we got our table filled in. Now let's extract some equations. Coming down this column, you know that if you deposit x here and y there and it's $100,000 total, then it must be x plus y is 100,000. And then here's the money that you're getting paid. So if you get paid 0.02x from the first account and 0.10y from the second account, and the total is 5,000, then those two things must add up like that. There's our 2x2 system of equations. And again, I'm going to ask you to solve that as an exercise, because I hope I already solved this. Come on, guys. Where'd you put it? Where'd you put it? Oh, here it is. Yes, I did already solve it, thank goodness. So you should get, make sure you do, you should get x is 62,500, y is 37,500, and you can always go back to the table if you're trying to remember what did x stand for. X stood for this. It stood for how much you're depositing in the safe account. So you can say, okay, in the safe, and this stuff goes in the aggressive. How do you spell aggressive? Something like that. There she blows. Okay. Now this, I can't resist this one last application. Now for something completely different. What are we going to mix together? We're going to mix some points. What? We're going to make the equation of a straight line. A straight line that goes through these 2 points. This is a cool way to do it. Now you probably have other ways like, oh, there's a slope formula, right? Yeah, you could do that. Or you could go like this, and this is kind of cool. I like this. I can dig it. Remember the equation of a line, the slope-intercept form anyway, goes like this. Y equals mx plus b. If you don't mind, I'm going to basically switch that around and say mx plus b equals y. So to get the equation of the line, we basically need to solve for what's the m, what's the b, right? 2 things to solve for. If we get 2 equations, we'll be golden. Where are we going to get 2 equations? Well, we know this line is supposed to, or this equation, I'm sorry, this equation is supposed to work here. When you plug in x equals 5, you should get y equals 8. And it should work here too. When you plug in x equals 25, you should get y equals 48. That's where we can get 2 equations, 2 unknowns. It's a good thing. So using the first point, using this point, when I plug in x equals 5, I have m times 5, which is 5m, plus the b equals the y is 8. Do the same thing with this point. You plug in the x equals 25, so m25, which is 25m, plus that b is equal to y is supposed to be 48. A 2 by 2 system of equations, which isn't even all that hard to solve. In this particular case, you don't get decimals is what I'm saying. It comes out nice. So, I don't know. What do you say we multiply this equation by -1? So I'll have a -5m and a minus b equals a -8. So if I then add these 2 equations together, I'll have a 20m, and the b's will go away. That was the point. Equals a 40. Divide both sides by 20, and well, that was quick. M is equal to 2. Woohoo! And now you can come back to any of these equations, like maybe this one. In fact, let's change colors here. Brown. I don't use brown very often. So you got 5 times the m is 2, so I'm plugging it in up here, plus b equals 8. So that's a 10. So quickly you find out b is equal to -2. And so here's your equation. It's m is 2, so 2x plus b, which is -2. So that's the equation of the line that goes through these 2 points. Cool, right? So you can use 2 by 2 systems for pretty near anything. Alrighty. Let's do some homework or something.